Hello everyone, welcome to the CSE116 Task 5 overview. Wow guys, it has been a lot of tasks. Task 4 was, hey, recursion. I tried to warn you guys. I really tried in Task 2. And many were lost in Task 2. But that's okay, because now we're on Task 5 and we're on to greater and better things. We're all better programmers now. And let's get into some strategies that I would recommend for this task. Now, this task is different because this task, we don't tell you exactly how to do something, and there's a lot of room for interpretation. So a lot of what this task comes down to is how you design how to implement the inventory in this case. And there's not really too much conceptually that I could talk about here at all. So we're gonna go through the doc, and I'm gonna explain some strategies of how to design a program that you have to make completely yourself. You have to design, and what to think about when you're trying to implement something like this. So let's go to the doc. Okay, we're at the doc. Before I even go through this, actually, I'm going to show you guys what the game is going to look like after you implement it, if you decide to add some of these features. So you see we have these three pickups. I'm going to pick all these up right now. And you're probably used to seeing this shooting thing. But now I have stuff in my inventory, and I could cycle through it. So if you look in the top right here, you can see I'm cycling through things in my inventory by pressing tab. So I have an axe, magic, and a health potion. If I equip the axe and then shoot the axe, I have an axe that I'm throwing. And you can see it's definitely slower than the magic projectile here. So it's a different weapon. Oh yeah, and I accidentally just used the health potion, but it heals you. And then it gets used. So now I'm cycling through it again. I don't have either. So also something I found that was just kind of funny is if I shoot an axe, I could break it with the magic, which is kind of cool. But so yeah, that's just basically what's going to be different. You're going to implement some things for your inventory. You could use new items. Um, and yeah, so it's not too much like actually different, but that whole inventory thing is pretty cool, and you guys are going to implement it. So this right here is worth reading. It's just basically telling you how to change animations on an object. Like you saw how that axe was like animating and rotating when it was like flying through the air. So this is worth just a read. And if you guys are confused about like how it actually how to do it, like if this doesn't make much sense, just go to the player class and you can see how it's done there as well. Like you just read it because the player's animated at points. Okay, moving on to specification stuff. So a lot of this stuff is stuff that you guys have seen like in pretty much every single task. Like for example, just telling you, okay, go to the projectile, add a getter and setter for damage. You know, like this is the stuff that you guys should probably be used to by now. Um, you're making some new classes like a player axe projectile, player magic projectile. You're using inheritance again. You are extending from the projectile class because, as you just saw in the game, we're making new projectiles, and so it like some of these things like it's not gonna directly tell you. Like for example, it says like this projectile should always deal 3 damage. You know that probably means like we have to give. Maybe we're not gonna include a damage parameter in the player magic projectile class or constructor. Sorry, because like we're always gonna pass projectile 3 damage maybe. You know, it's like stuff like this. Like sure, it's a little bit of thinking, but like at least you guys are probably used to this stuff by now. There's not too much for me to explain there. And yeah, here's the animation thing. You're gonna add that for the X, like you just saw. Um, okay, and then you're gonna make something called a collectible game object. You could think about this as like a pickup, an item, whatever. Um, and it extends dynamic game object, and this part of it you guys are used to. Except here you're making an abstract method because it's an abstract class. And if you don't remember, abstract classes cannot be instantiated on their own. Only their children that inherit that abstract class, as long as they are not also abstract, they could be instantiated. So abstract classes are just like our way of saying like, okay, we're gonna make something that's a template for a whole bunch of other classes, but we never want to instantiate it itself. Like what would be the purpose of ever instantiating a collectible game object? Like maybe we'd want to instantiate like an item or sorry, not an item, a health potion or, an axe like you guys saw on the floor earlier. I picked that up. So, yeah. So collectible game object, it's just a class to make. This again isn't where the majority of the bulk of the task is. I want to focus on that because this is what's going to cause you guys probably the most trouble, which is ducks are outside. Um, it's the inventory. So you have to implement an inventory system, and we don't tell you how to store that data behind the scenes. All we are asking for are a few methods that do what we want. So, for example, when we add an inventory item, we expect that that item is going to be in your inventory now. When we remove the active item, so yeah, for some clarification here, the inventory is its own system. You guys could store that data as you want, however you want, and that's the trick of this project. There is no us saying, okay, make this data structure and put this in there. There's none of that. It's you guys have to pick that yourself. So how you choose that is completely up to you. And you could think of a few different ways to do it. There isn't a like we're not looking for a best solution here. There could be many different ways of implementing this. Um, and how it works is that you have some inventory. We add items to it. Um, and then there's one item in there that's your current active item. So like when I had the axe like in my hand, you could think of it as I could use the axe, right, if I hit space. Um, and then when I hit tab, I cycle through the inventory. So that's also a method you have to implement, cycle inventory, which moves the active item to the next item in the inventory. How do you implement that? That's what we're going to talk about a little bit here. So, when we as programmers are presented with the challenge of designing something ourselves, the number one question we should ask is what do we need? What resources do we need to implement this feature? So, for example, we have an add inventory item and the user expects that when they call this method and give us a collectible game object, we're going to add it to some inventory somewhere and be able to access it later. So right off the bat, we need some way to store the data. Just in general, the very first thing we see is we have to be able to store inventory items somehow. So it's helpful to write these facts down. So I'm gonna create just a box here and label some facts that we need. So we already said we need a place to store items. That's a fact. And sometimes it's helpful for me to do this because I like to see everything laid out and then design the program after that. Okay, and then the next thing we see is remove active item. Okay, so now we not only need a place to store that data, but we have to be able to remove the active item from that data. Now, right away, I'm not currently understanding what the active item is, so I'm going to hold that to the side and think about that a little bit later. Okay, add a method named getActiveItem that takes no parameters and returns a collectible game object. Okay, so I'm going to need some. I'm already seeing like, okay, now two places reference this active item. There's something even called an active item. I'm already thinking like, okay, I need some way to keep track of this active item. Like, how else am I going to get it? Somehow I have to remember what this active item is at all times, especially if the user might want to get it often, considering there's a get active item and a get active item ID. So there's a very good chance that this gets called all the time. So I do have to keep track of this active item. So already I see that's something else that I need to keep track of. Um, I don't only need a place to store items. I need um, to somehow keep track of the active item. Okay. So that's the next fact that we need. Um, Add a method called cycle inventory that takes no parameters, returns void, and this will cycle through the inventory, changing the item currently marked as active. Okay. So if we're not even thinking about programming, and like if we're just playing a game and we're thinking about cycling an inventory, I don't know about you guys. Right off the bat, I'm thinking about like the hotbar in Minecraft, where like if you scroll your mouse wheel, it'll go all the way to the end and then go back to the start. So I'm thinking about something like that, and maybe the hotbar is the active item. Except it always has to be something in there, but it's just it's making me think about something that I know. Whoa, 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 Josh, I'm gonna stop you right there. Now, it's important for me to point out in hindsight that I need to clarify there are some differences from the Minecraft hotbar, but it does still remind me of the Minecraft hotbar. So here we have a classic Minecraft hotbar. If you've never played, it's basically just or you have a set amount of 9 slots, and each of those slots can hold an item. And you currently have one item in your hands, not including your offhand, which is indicated by this highlighted box. Now, there are some key differences from the inventory that we need in the Minecraft hotbar. It does still remind me of it though, and I'll explain those differences. The main difference is that we don't have a set number of items in our hotbar. Like in the Minecraft hotbar, there's always 9. Like we literally see like one, two, three. Like it goes up to 9 here. But in our inventory, we could if we called add item to inventory, we could technically see another item get added right here. It would always go to the end of our inventory. It looked like something like that. And then our hotbar would just be longer, I guess, when we cycle. But still, what is true is that the active item thing, the cycle feature. So let's say like we scrolled our mouse, then the active item would be this. Then if we scrolled again, it would be this, and it would have to go in this order, right? And it can never go back though. It has to keep going forward. So we're calling cycle active item, and it's going through cycle active item, cycle active item, cycle active item, and then at this point, if we called cycle active item again, we would expect it to go back to the start. And then the very first item would be our active item. Um, so that is true about this thing, about cycle active item. It always goes through that behavior. It always goes forward. It can never go back. And when it reaches the end, it has to go to the start. In that sense, it can go back. But what I'm saying is like you can't go. Oh, whoops. What I'm saying is you can't like cycle back an active item. It's just cycle active item. You go forward. You cycle forward. Um, but another thing that's important to note is let's say our active item was this right here, and we called remove active item. Now our hotbar goes from 9 to 8, and this slot here no longer exists. This is like it's gone. Let's see if I could. Yeah, I don't really know how to do this, but yeah, I'm just gonna keep going. Yeah, it's gone now. It doesn't exist, and now let's say after we remove this item, and this was our previous active item, our new active item would be this. I'm gonna use a different color now. Our new active item would be this, and then we'd call cycle. We'd go here, and if we kept calling cycle, eventually we would get here. And if we called cycle again, we should expect it to go here. Okay. So our inventory has to be dynamically growing and shrinking based on like remove active item, add active item. Um, so that's something that we just have to keep track of. And how you guys choose to do that, it's up to you again, and I'm going to go more into it. But whenever you hear me mention the Minecraft hotbar again, remember that like it's not identical to the Minecraft hotbar, but it does give some similarities, and it reminds me of it. And yeah, you could kind of go through it and see again, but yeah, just want to make sure I put that in there.
Chicken jockey!
So because of that, I'm going to remember that like, okay, it kind of makes me think about the Minecraft hotbar, just so like I have something where I'm like, okay, this feature I'm trying to implement might be kind of similar to something that already exists. So it's just helpful to make those parallels sometimes. So I'm even gonna write to the side, just like reminds me of Minecraft hotbar. Just like so I remember like, oh yeah, it is kind of like that. Maybe this works like this, and this isn't like necessary. I'm just doing this for myself because I'm like, well, if it works similarly to that, I've seen that thing a lot. I've used it. I know how it should kind of feel. And right off the bat, I'm like, wait, if the Minecraft hotbar, once I get to the end of it and I scroll again one, it goes back to the start. So before I'm even reading anything else in cycle inventory, I mean, it's called a cycle. So that already makes me think like, oh, so the active item at the very end, once it goes like past one, it has to go back to the start. And that's something that is specified here. So I'm like, oh, okay. That increases the complexity of the active item. Not only are we going to have to move it to the next item in the inventory, but we will have to cycle it back to the start. So that's definitely something that matters a lot. So I'm gonna say probably something like not only we have to keep track of the active item, but we have some, or let's see, um, have a way to advance the active item to the next inventory item, um, and must be able to cycle. Okay, so this box got too small. So, oh wait, there's a scroll box here or something. Whatever. Oh boy. Okay, somehow deleted the whole thing, so I had to retype it, but it's back. Okay, so yeah, I need the stuff, and I I was just thinking, yeah, it has to be able to cycle. Like the active item has to be able to go through the whole inventory and then go back. That's just how it works. It's how it's defined in the doc. That's how I remember it from like something I already know that's kind of similar to it. So, all right, that's something that I'm going to need. And then now I could see like, okay, go back to remove active item. Now I know what an active item is. I know what it reminds me of. Now I have to have a way to remove it. And because of everything we just talked about, I'm already thinking like, oh, this could be hard. And it could be hard because the active item may be somewhere in the middle of the inventory, but it could also be at the end of the inventory, the very last item, or the very first one. And every single one of those cases might be a little bit different because if I'm removing the active item, what does that even mean in my system? Because, I have some place to store items. So, whichever one of those items is the active item, I have to remove that and no longer have that in my inventory. So, immediately I'm going to foresee like, okay, remove active item is going to be a problem. That has to be included in the design. Somehow I have to have a way to remove the item and completely get rid of anything else from my data. Now, I'll say right now, like, I'm going to probably put, like, something that indicates for me that it's urgent. How to remove active item from storage. Because, oh, and also when we remove the active item, we have to set the old active item to whatever's the next in the inventory. Which that part that makes a little more sense to me at least, because like say we have a whole bunch of items in like, or let's say we have like a whole bunch of items in like that hotbar, for example. If we were to remove a hotbar, it would be the next item. It's like the same thing as cycle in my eyes. Like okay, just once we remove that item, we have to be able to cycle. Now it's just the whole thing where it's about removing the active item. So, um, some of you, when reading this, you might be thinking about a data structure to implement it. Some of you might be thinking about a different data structure. And the answer is do whatever you think is going to work. And don't get too hung up on if it's the best way. Do think about it for a bit and be like, is this how I should implement it? And if you're having trouble, it's normal when you're thinking about something new. Like this is a task where it's like, all right, we're giving you what we want. Now you give me some way to implement it. Because all I expect is something back. Like all the user expects is for when it calls remove active item, it just expects that item to no longer be in the inventory, and that's it. So the behind the scenes thing is of course the hard part, but it's also like if we just think about it that way, where we're given this like medium where like the user passes through, and at that point, that's when we have to actually do stuff. So, you know, adding items, removing items, getting the active item. We have to have some state. Like we have to have some way to control the active item. These are the things that I immediately thought of. Maybe to you guys, you thought about something more, you know, apparent and necessary that you'd have to write down here. Um, but all in all, for me, with this to the side now I have somewhat of an idea of like, okay, where should I start at least? I know for a fact that I have to store items. Maybe I'll, implement some data structure and see how that works with adding, and then maybe I'll keep track of some active item. And then when it gets to remove, for me, I see remove as like, okay, that is definitely a problem. Maybe I'll include that in how I decide to store my items. Like, I'll think about remove when I think about what data structure I want to use. Maybe. But even if not, let's say I implemented all of this. Now I have a smaller problem. I have all this made. Now I have to figure out how remove works. Um, so yeah, inventory. It's definitely the hard part about this task, and don't feel bad if you're struggling with thinking about how to do it, but do honestly think about it for a little bit before you implement it. Think about how it should work, write some stuff down, and then start typing code and try some things, see if it works, write tests. Tests in this task are probably the most important yet because, and I think it's even recommended that you write them first. Um, because those if you write good tests first, you'll be able to know if these methods for your inventory are actually doing what you expect. And so like if you even write your tests, make sure they pass an autolab and then go to your actual code implementation, you'll know that like it works if your local tests pass. So that's probably something that I would do. And then honestly, like all the rest of this stuff is like nothing new. Like you're making a magic pickup, which is like a way to pick up something and add the item to your inventory. But it's like this is stuff that you guys have done like over and over and over again. And you guys aren't gonna like see exactly what I had in my game because I added those dynamic game objects to like I added that axe pickup to the dynamic game objects list. Like you guys have seen before, I think we did that stuff in task 3. So yeah, if you wanted to add it to test it out in the actual game, which you probably should, that's one of the best ways to test your stuff. Um, then I would do that as well. And luckily, uh, well, not so luckily, but less work, I guess. There's no testing utility, and then the testing requirements seem simple, and honestly, they are somewhat simple. Because you just expect some behavior to be true, and the actual implementation doesn't really matter. That's kind of what like we're saying. Like you guys can implement it however you want as long as it works. And we just expect some things to happen. As long as all this stuff is true after we call that method, then how you implement it is totally up to you. And the way I wrote it down here is just stuff that helps me implement that feature. And writing down different stuff or having a different strategy could help you. But of course, I don't want to say exactly how I did implement it for the game that you just saw at the start of the video because I do want you guys to like think about it yourself, and I'm sure that is the whole point of this task, to try to get some creative thinking because that is being a programmer. Thinking about what to do, how to implement it, assessing what you have available, and then trying it out. Um, so yeah, that's kind of it for this task. It's I don't have too much more to say because if we go through all of these things, it's just like okay, make override the collide with dynamic game object, at call at an inventory item, replace action button press to use the use method. This is just stuff like if you were to watch any other video for me explaining like how to implement one of these methods, like an override, that's like the inheritance task. Adding constructors, that's like task 1 and 2. Um, and then like stuff like the suggested sprite sheet file name, that's task 3. It's like this stuff is the stuff that you guys are used to by now, and there's no new algorithm that we're learning. The only thing that's different is you guys have to pick yourself how to implement the inventory data and how to make these methods actually work. That's up to you. So, um, if you do go to office hours for some help, try to like ask some conceptual questions to try to help you understand just the general idea more, rather than just saying like, well, how do I do it? Because that's kind of not the point for this task. We don't want to just tell you like, all right, so the best way to do it is this. We want you to figure it out yourself. Even if it's not maybe the best optimal way, you guys are going to be very satisfied when it works, and it's because of your implementation yourself. So, I think that's pretty much all I have to say for this task. Yeah, that is pretty much it. So, everyone, I hope you all have a great day. I hope that you're gonna get this one by everyone's gonna get the one by the expected deadline. No one is gonna fail the course, and that's about it. See you guys next time.